All right, so we've taken a look at the molecule shapes and we've drawn Lewis structures with our lines and whatnot. But what do these lines actually represent? So we're going to take a look at a couple of advanced theories of bonding. Some of this can get a bit complicated, so make sure you take a look at the work along in the homework check for kind of what you're expected to know how to do. But anyways, first off, we have valence bond theory. And so this has to do with orbital overlap. So think about the electrons that we learned. We learned that they were in certain orbitals. Right, those are S, P, D, and F orbitals. And these electrons are in there. And what what valence bond theory says is that these chemical bonds are formed whenever we have overlap between half-filled orbitals. So this really works for well for SH2. So sulfur, remember its electron configuration. It has 2 electrons in the 3s orbital, and then 4 electrons in the 3p. So fill it up with 3, and then a 4th one there. And then there's 2 hydrogens. Each one of them have 1 electron in the 1s orbital. And so valence bond theory says is that we have the sulfur here, right? Then we have our 3s orbital. That's filled, so that's not going to bond with anything. Then we have one of our p orbitals is also filled, so I'll make it this kind of north-south one. And then we have our other 3p orbitals that are each half filled. And then these half-filled orbitals interact with the hydrogen 1s orbitals to create our chemical bonds. And then if you think about the predicted bond angle here, this would be 90 degrees, which is actually pretty close to the bond angle in SH2. So there we go. That looks pretty decent. Unfortunately, this doesn't work well for most compounds. And so there's a modification that we can make on valence bond theory to make it work pretty well for most organic compounds.